as you think of a question, put it in the chat, and that way you don't have to remember it. As you can see, all the YLE staff have Den's Day signs behind us, and we're wearing our t-shirts. Mine doesn't really show. There it is. So we have our t-shirts on. You got an email from me last night. And Heidi, do you see that? Can you help? You got an email from me last night about Den's Day. And so Den's Day is the last day of class at Furman. And so there's lots of hoopla for the students, and especially the seniors. It's their last day of class. And one thing they get to do is get in the fountains legally. When I was a Furman student, you had to sneak and do that at midnight. So I think it might not be quite as much fun if it's legal. But anyway, they have all this stuff. And so there's a big fundraising day around that as well. And so there are ways that you can support Furman. The email I sent you has a link that takes you to the site where you can give to centers and institutes. And then you can choose which one. So of course you can choose YLE. You can also choose the SHI Center. So if you like what you hear today, Wes would love for you to make a gift to the SHI Center if that is something you are interested in. So I will hand this over to Sarah Fletcher to introduce our speaker, and we are glad you're all here.
Hi, everybody. I'm glad you're here. Dr. Weston Dripps is often called Wes by many people. He grew up in suburban Philadelphia and went on to study geosciences at Amherst College for his bachelor's degree. He went to Dartmouth for his master's and University of Wisconsin-Madison for his PhD. I did too, Wes. All right. In between degrees, he worked as an exploration geologist in oil, gas, and water. He was an environmental consultant, a hydrogeologist, a high school teacher, and an outdoor educator in the Swiss Alps, as well as a nightclub disc jockey. Before coming to Furman, he was a researcher at MIT in the Department of Environmental and Civil Engineering and assistant professor at University of Massachusetts, Boston. Since 2016 at Furman, he has served in a dual role as professor in Earth, Environmental, and Sustainability Sciences, and in his spare time, the executive director of the SHI Institute for Sustainable Communities. He has been very involved, obviously, with the university's sustainability efforts and sustainability student living communities. He is a very admired and loved professor here. He has won both the university's Meritorious Teaching Award, Meritorious Advising Award, Student Organization Advisor Award of the Year, and Engaged Living Awards. He's given over 100 presentations at professional meetings and published more than 20 peer-reviewed journal articles in his research. And today's topic is very important to all of us. Crisis climate tipping points. What can we do? Here's Wes.
All right, let me share my screen here. I'm going to, give me 1 second. All right, Sarah, can you see that? You can see my screen now? Thumbs up? Excellent. Well, great to see everyone, virtually, of course. Yeah, as Nancy was sharing, it is an important day today. It is Den's Day, so we're all celebrating the last day of classes. I myself, I had 2 in-person classes this year, and we made it. We made it to the end. We did a great job. So I'm really ecstatic and excited, and excited to see the students being able to kind of celebrate this huge accomplishment given the pandemic. As Sarah mentioned, I have a dual role. So I teach in Earth, Environmental, and Sustainability Sciences. I'm trained as a hydrogeologist, so my specialty is in water. But for the last 4 or 5 years, I've also been the executive director of the SHI Institute for Sustainable Communities, really focused on the campus sustainability and community sustainability issues. I thought what I would do with our time, I know our time is kind of short, and again, I never know who I'm talking to in terms of where they are on the climate change kind of timeline in this, but I thought it'd be useful just to give a little bit of review of just some of the basics around climate change, and maybe hopefully destigmatize and peel back some of the uncertainty that you hear about in the media and in politics, among other things. Look a little bit at the impacts, and then at the end, if we have time, get to maybe what can we do about it? What are some of the things we might want to do? I show you this picture as a start. So every year, NOAA goes ahead and puts together a compilation of the year's worth of temperature data. And again, this is from 2020. And this picture looks pretty much like the pictures for the last decade or so. I feel like every year it's a lot of red and not a lot of blue. And we seem to be on pace to kind of regularly set annual records in terms of the warmest year. And this is not something I necessarily aspire to. This is one of those prizes you probably don't want to win. Last year, 2020, tied for the warmest, second warmest, or I should say tied with 2016 as the warmest year on record. And I want to revisit that a little bit by actually bringing it a little bit closer to home by saying, you know, I can look at this picture, it's just 1 year worth of data, but when we talk about climate, we're talking about a trend. And so what is pictured here is actually the running 30-year average of temperature from the 1900s all the way to present day. And you don't need to strain your eyes a whole lot just to look at the colors that change from blue to progressively red as we move along to realize that the United States is warming, and we've been warming pretty systematically over the last 100 years or so, particularly so in the last 30 to 40 years. You've seen that the US has gotten quite red, as it showed there in the 1991 to 2020 kind of average. In particular, you'll notice that the Western United States and the Southwestern United States is a deep red. And I want to start my story there on something that is a little bit closer to home for me as my hydrology side, that really hammers on the idea of there is a difference between weather and climate. I think we've got to remember the difference between these, because I think sometimes the media and certainly some of my climate change denier friends are quick to point out to me, you know, the minute we have a cold day, they're like, see, where's the global warming now? We had a frost last week. How do you explain that? And I have to remind them that weather is what happens day to day. It goes up, it goes down. There are warm days, there are cold days. When we talk about climate, we're talking about these longer term trends. That said, I think all of you are probably at an age where it doesn't take, besides the science I'm going to show you, if you just think back over the last decade or last even 15 years, it's hard not to realize that there's a lot of kind of these indicators that things are warming. I feel like the spring is coming a little bit warmer. I seem to plant my garden a little bit earlier every year, much to my demise, and that late frost spring always seems to wipe it out like it did last week. Catastrophes seem to be always in the news in terms of whether the hurricanes are getting stronger or the flooding's getting worse. So I think we've all kind of experienced it in some kind of personal way to a certain point. But I have a student in my class, I'm teaching a watershed hydrology class, who lives in Phoenix, Arizona. And I've been following the news very closely about what's happening actually right now out in the US Southwest. And I know this is weather, but I pulled up the forecast for Phoenix, Arizona this week. Remind you, we're in April right now, okay? This is not like July or August. The temperature in Phoenix, Arizona on Saturday is gonna hit 103 degrees. Now, again, I know this is weather, and this is maybe a temporary heat kind of rush coming through. But if you look at those temperatures, 99, 103, 99, 93, 90, again, this is April, early May. And I'll partner that with the picture on the right, which again, it doesn't take a scientist to realize we have a problem here. This is a picture of Lake Powell. This is one of the water one of the water reservoirs from which actually large parts of the US Southwest get their water, the other being Lake Mead. But right now, both Lake Mead and Lake Powell are moving towards historic lows. And you can see in the middle there, here's a marina that sits in the middle, but you can see actually how the water line has receded. And unfortunately, we're headed into the hot summer where that recession is going to get worse and worse and worse when people need water more and more and more. And it gets overshadowed, I think, by a lot of the other news and the pandemic and all these other things. But if you look and go look at what's called the US Drought Monitor, you can Google this. It's every week they update the drought status across the United States. And this was it from just last week. And you'll notice here in the US Southwest, we are in exceptional drought. I mean, exceptional drought, some of the worst they've ever seen. And I'm hearing now rumors and murmurings that we may even have to go into some water rationing as we move into the hot summer months for the states of Arizona, Nevada, and even Utah. which is not good news for that area of the United States. Now, some may say, oh, it's just a drought, it's kind of passing. And I won't necessarily say this is all climate change, but the fact that we're having this conversation year in, year out, and in fact, this current drought has just gotten deemed what's called a mega drought, meaning that this trend has been persisting now for almost 2 decades. I do think this has the fingerprints of climate change kind of all over it. And something that you have to realize that if that water in Lake Mead or Lake Powell drops too far, that is the lifeline for the whole city of Phoenix, Las Vegas, major cities across the United States where you could see them physically running out of water. I don't think we'll get there because they're likely to cut off all the water to ag as opposed to domestic use, but there's a lot of agriculture we get from California, Nevada, Arizona that fills our grocery stores that is likely to take a pretty significant kind of impact. One last thing on this is the hydrologist in me. You can also go Google Lake Mead water levels, and you can see in real time what the water level is on Lake Mead. And to put this in perspective, the top line up here was what the water level was in 2020. The blue line is where the water level is right now in 2021. And so already in just 1 year, it's down almost 7 or 8 feet from where it was last year. And again, we're heading into the dry portion now where it's going to continue to drop all the way through the summer months and into the fall. There is a threshold beyond which if it drops too far, as I mentioned, that you're going to have to go to water rationing. And that's a huge concern. Arizona, in particular, Phoenix, are some of the fastest growing cities in the United States, and unfortunately, probably some of the most unsustainable. All right, I'll get back to climate change. Sorry, it got me off on a tangent, but I feel like people talk about it doesn't impact me. And in fact, there was a study done by Yale just recently that does this kind of polling of people around the United States. And there's some good news and bad news in this most recent poll. This was a question that simply asked, do you believe that global warming is caused by human activity? I guess the good news is that number has consistently come up through the last couple of years, again, as people maybe experience it more personally. But the sad thing is it's only 57% nationally, which means there's a 43% group that doesn't believe that we are somehow tied or responsible for climate change and global warming. And there's some states where it is below 50% that you can see highlighted there on the map. To me, that's the fact that we're at a point where we're even debating whether humans are impacting or not. I'm hoping to show today that we definitely have a footprint. It's definitely happening, and we can get beyond the rhetoric now of whether we're responsible or not and think about real solutions about what might be done to kind of address it. The other piece, again, that I think could hit home really, really quickly, as I mentioned with the drought example I gave in the beginning, is only about 43% nationally believe that global warming is personally impacting them. I promise you, if Lake Mead or Lake Powell drop below that intake and you shut off the water to the city of Phoenix or Vegas, they will say it personally impacts them. And you're talking millions and millions of people that will be directly impacted by this drought. I would say the same, California maybe is first and foremost because of the wildfires and other things that have really kind of ravished that area. But I am kind of surprised that no other states in the United States do more than 50% feel that somehow climate change is impacting them personally. And again, climate change is here, it's already impacting us. And if we don't kind of do something about it, it's going to get only kind of progressively, maybe a little bit worse. All right. Let me do basic science kind of, because I feel people say, oh, climate change is really complex, it's confusing. Yes, there's a lot of complexity, but the basic premise of climate change and the idea of global warming is actually pretty straightforward. So what you see on the screen right here reflects what's known as the greenhouse effect. The idea basically that the sun lets down UV light and visible light that has a short wavelength that is able to penetrate through our atmosphere and come down onto the surface of the earth. And as it actually gets absorbed, it gets re-radiated as infrared, which has a longer wavelength, which makes it harder to penetrate out of the atmosphere, and therefore it gets kind of trapped by this atmosphere that is filled with greenhouse gases. I will say that people, greenhouse gases kind of have a bad rap, but greenhouse gases are also what make our planet habitable. So greenhouse gases themselves aren't bad, but too many greenhouse gases is going to actually directly impact how our climate kind of functions. You've all experienced the greenhouse effect, whether you know it or not, whether you've been in a greenhouse, hence the name of the greenhouse effect. A greenhouse is made of glass. It allows that UV and visible light through, but it traps then the thermal energy and the infrared that then tries to get back out, that gets trapped within the glass, that causes the greenhouse to warm up. The same is true if you were to hop in your car and go up to Publix to grab a sub, and you go into Publix and you leave your car and the windows closed and you come back out, and lo and behold, when you get in the car, it's warmer in the car than it is outside. And your car's doing the same thing. The glass on the windshield and the windows is allowing that UV and visible light actually in. It's being captured inside your car, and when it tries to escape as infrared, it actually can't penetrate the glass, and therefore causes your car to warm up. This is the same phenomenon. Now just scale this to the globe, where instead of glass, you have these greenhouse gases that exist in our atmosphere. And we talk a lot about carbon dioxide, but I would be remiss if I didn't say there are multiple greenhouse gases, including water vapor, which again are very important in terms of regulating our climate. We seem to focus on carbon dioxide because that's the one where humans probably had the most direct impact in terms of actually increasing or augmenting the carbon dioxide levels in the atmosphere. But you're also hearing increasingly more about methane. Methane is a more potent greenhouse gas, and one that actually is being emitted from a lot of landfills. It's being emitted, as we hear about, as concerns over the permafrost melting, but places where you have anaerobic breakdown or decomposition of organic material, you can get methane being flared off or emitted off. Also, the fracking that is happening now with a lot of natural gas exploration, there's concern that there's a fair amount of methane escaping from that. And then, believe it or not, even ruminants. So cows and other animals that burp and belch actually can generate a fair amount of methane kind of as well. Nitrous oxide comes from our fertilizer use, among other things. It also is a pretty potent greenhouse gas, but it's not generated in as much quantities as say carbon dioxide. What's interesting about carbon dioxide is it has a pretty long lifespan in the atmosphere. So it's not something that's easy to clean up quickly. So as we emit carbon dioxide in the atmosphere, it can linger up in the atmosphere for 50 to 200 years. So this is a long-standing problem, and one we need to realize that there often then is also a lag between our actions that happen now and maybe the impacts that are associated with global warming that then follow. You'll see that methane's on there. It's 21 times more potent than carbon dioxide, but a much shorter lifespan. And then some of the more synthetic, what are called chlorofluorocarbons that are used in a lot of refrigerants are very potent, and one I'll come back to kind of as we progress through the talk. So how do we get carbon dioxide into the atmosphere and where does it go? Well, really carbon dioxide, there are two major sources that put carbon dioxide in the atmosphere. The one that you're probably most familiar with is the burning of fossil fuels. So coal and natural gas and oil, when you combust those release carbon dioxide into the atmosphere. And the other one then is what we call land use changes. And this is deforestation that results from a lot of, whether it's development or expanding ag at all scales, I mean, locally, but also globally, all the way up to things like the Amazon, where as you cut those trees down, you basically release a lot of that carbon dioxide because it's no longer being kind of sequestered. Once we put it in the atmosphere, it has to go somewhere because we have to balance the carbon budget. And so where can it go? Well, it can go one of three places. Some of it does get taken back up in terms of the land. So there is some greening or maybe a positive effect in terms of trees like CO2 to take up through their photosynthetic process. And so that's actually a good thing. But the bulk of it you'll see there is ending up in our atmosphere or in our oceans. And so oceans can assimilate a fair amount of CO2 where the water in the ocean combines with CO2 to actually form a weak acid or carbonic acid that is unfortunately making the ocean very small, but increasingly more acidic, which has concerns over the ecosystem impacts. But we'll focus really today mostly on the atmospheric component of it because a lot of it ends up there. Let's look at some data because I'm a scientist and I like to look at the data and try to keep the politics and the personal opinions kind of out. And so I want to share with you probably the most famous of all the CO2 records that has been ongoing since the late 50s on the top of Mauna Loa Observatory, where they've been making atmospheric measurements of CO2 on a continual basis. And what you see plotted here is the CO2 in parts per million through time. And again, it doesn't take a scientist quickly to look at this and realize it's increasing. And it's increasing at a pretty steady clip and a steady pace. And one thing that's interesting on it, you'll see is the red line is the actual monthly data. And if I zoom in on that monthly data, I find this fascinating again as a scientist. There is a natural seasonal cycle in CO2 that is easy to observe in the data at Mauna Loa, where I would really say this is almost like the earth breathing. So as trees bud out here in the April months or so, they actually sequester a fair amount of carbon dioxide, which causes the level to drop until into the fall when deciduous trees lose their leaves and they kind of cut back on the photosynthetic process. And then lo and behold, it increases during those overwinter months and into the early spring, and the process kind of continues. Some may say, why doesn't the Northern Hemisphere and Southern Hemisphere kind of equal each other out, because their seasons are exactly inverse? And the answer to that basically is there's a lot more land cover in the Northern Hemisphere. So the Northern Hemisphere is got a lot more land mass and a lot more trees kind of in it that allows you to see then that Northern Hemisphere signal in the seasonality. So there is natural variability that is something completely natural, but you'll notice that the trend is definitely upward in addition to that seasonal variability. And that's the concerning part where we as humans are really contributing, as I mentioned, through both deforestation, but also increasingly through our dependence and use of fossil fuels. If we scale this back, I'm a geologist, so I like to look further back in time. So if we expand the scale, still looking at CO2 concentration, and now look all the way back into the early 1700s, this starts to put it a little bit in perspective in terms of really saying, wow, you realize that the last 50, 60 years, we've seen a significant increase in the amount of CO2. And if we want to go back even further geologically, now we're back into the 800,000 year record that we get from ice core data from the, Antarctica, where we can actually, it's amazing, the ice can actually capture air bubbles from the time at which that atmosphere and that ice was made, and we can analyze that to look at what the CO2 concentration is back historically. And the one thing I want to point out is people say, oh, it's a lot of the times they'll say, oh, CO2 naturally varies, it naturally fluctuates. And they're not wrong in saying that, but I just want to point out where we reside. We're up closer to 419 parts per million nowadays. And you'll notice that historically, geologically, at least for the last 800,000 years, we've kind of bounced between 180 and 300. So we are well outside that kind of natural fluctuation that we might expect due to a large number of other forcing functions. All right, so a couple things on the effects. So again, I made the science simpler than it is, but I do want people this, I think sometimes they kind of hear that say, oh, it's too complex, I couldn't possibly understand it. And honestly, if you just understand the greenhouse effect, that really is at the root of what we're seeing. The science behind that has been well known for a long time, and I don't think is overly complex. The complexity gets into the compounding factors and the interchange, interconnectivity of all these things. But I do want to highlight what we often think of as the big three when we talk about climate change. That would be increasing temperature, rising sea level, and changing precipitation patterns. So I want to say just a few things about these effects. And again, I'm going to pull in some data just to kind of highlight maybe where we're at with these. The first one is I showed you the CO2 rise, but you may look at this. This is the temperature rise and say, hey, it looks very similar to the CO2 rise. And the answer is yes. There is a definite linkage kind of between these, as you might expect. As we increase the amount of greenhouse gases, we would expect the temperature to increase. And in fact, that is what we see. So we've had a pretty steady increase. It does bounce around a little bit, but again, we're interested in the trend on this that is continuing to rise. If you tease this out a little bit more, you'll notice that actually the temperature change at the land level is even more significant than the ocean. And that's because if you've done much cooking, you know, a watch pot never boils. The ocean can actually assimilate a lot more heat in order before it has a temperature shift than say a land mass. And so we actually see increasing temperatures on the land being even more significant than they are in the ocean. Furthermore, when people look at this, they always say, oh, but it's just a degree. Well, I want to point out that actually it's not evenly distributed. It may be globally 1 degree, but if you look at the average just from last year, the color red, the deeper the red, the bigger the change. You notice up in northern Russia in particular, in some of the permafrost areas, we're seeing anomalies that are more like 5, 6, 7 degrees Celsius, upwards of 10 degrees Fahrenheit out of normal. So yes, maybe 1 degree globally, but there are many areas where we're seeing very, very significant changes in the actual temperature with time. And part of those, one that I'll point out that is a little bit troubling, is you get these feedback loops in science. So one of the things up in northern Russia, where you have a lot of permafrost, I mentioned that permafrost holds a lot of methane actually in it. And if you begin to melt the permafrost and release methane, that adds more greenhouse gases, that causes more warming, which causes increased temperature, which causes more permafrost melting, which causes more methane. You see where I'm going with this. You get into these feedback systems where they can kind of run away. And we've seen this in the Arctic sea ice as well. So normally the North Pole is covered with Arctic sea ice. It's got a nice kind of white color to it, highly reflective, that as the sun's radiation bears down on it, it has what's called a very high albedo, meaning reflectance. So a lot of that energy gets immediately reflected back. The ocean, by contrast, is a darker blue. It has a darker color, and therefore, instead of reflecting, it has a lower albedo, and it absorbs actually a lot of that thermal energy that's coming in, or the radiation that's coming in. So again, if we warm the ocean and we cause Arctic sea ice to begin to melt, we expose more ocean, which means more energy is getting absorbed by the ocean, which causes the ocean to warm, which causes more ice to melt. And again, you begin to see this runaway feedback loop where the Arctic ice begins to recede actually quite drastically. And this is what we've seen, unfortunately. And you can see the data here that shows just how, again, it is more in the trend. There are years it's colder or warmer, where we see it maybe surge or ebb. But overall, we've seen a pretty progressive trend going down in terms of Arctic sea ice. This is true on Antarctica. This is true on Greenland as well. So if you look at any major ice sheet and any of our even land-based glaciers, you'll see the same trend of it progressively shrinking or diminishing the size of the ice field itself. This leads to the second concern, which is where does all that land-based ice, when it melts, go? And the answer is it goes to the ocean. And that's going to cause then sea level to begin to rise. So if we want to look at something that goes hand in hand with this, as we melt a lot of that land-based sea ice, so not the Arctic, which is ocean-based sea ice, which doesn't really change sea level, but Greenland or Antarctica or any of these land-based glaciers in the Himalayas and others, they're going to rise sea level. And so we've seen, much like the increase in temperature, much like the increase in CO2, we've actually seen a pretty steady, slow but steady increase in the overall sea level rise that has happened kind of across the globe. Sea level is rising for two reasons. I mentioned the land-based ice melting, but also I mentioned that the ocean has the ability to absorb a fair amount of that CO2 and a fair amount of that heat that is actually coming out of the atmosphere. And as you might imagine, when you heat up the ocean, even a small amount, it will expand itself. And when you get thermal expansion, it has to expand upwards because that's the only place sea level can go. It can't go down into the seabed and it can't go laterally. So again, between the ocean thermal expansion and the land-based ice melting, we're seeing a pretty steady increase in sea level rise. It's only a few millimeters per year, but through time that adds up. And if you live in Charleston, or some of the coastal areas, you're going to start taking notice of these. And again, I talked to my friends in Charleston that will tell you over the last decade, they're getting what's called sunny day flooding pretty regularly down there. It's not just limited to the hurricane season or other places where they have a big storm. we are actually seeing days where it's perfectly sunny out, and some of the higher tides, it's now flooding into the streets of Charleston or coming up through some of the storm drains, which again is concerning if you are a coastal resident. And there are a lot of coastal residents. I mean, we have a lot of cities kind of along the coast. So again, I do think if they're not already feeling it, if we don't do something about this, these are things that you're going to hear about more and more in these coastal kind of regions. The last one is precipitation, and that's a little bit more erratic. But overall, you can imagine if you increase the temperature of the globe, you're going to speed up the hydrologic cycle. You're going to cause more evaporation, which puts more moisture in the atmosphere, which causes more rain and more flooding and other things that kind of follow it. But with precipitation, you have to have the moisture available. So this is like the first graph I showed you with temperature. This is the precipitation change in the United States from 1900 to today. And you'll see that overall we're getting wetter, which is what we would expect, except the fact that if you look most recently, as I mentioned, typically climate change is going to dry out the dry areas and make the wetter areas more wetter. This is not good news for places like Phoenix, as I was showing you at the very beginning when we talked about this, because as temperatures go into 103 degrees in April, you got a lot of evaporation that is evaporating off any of the water that's there, what little there is there. And it's not necessarily resulting in higher rainfall because the humidity is so low. So there's been a lot of news about not only this mega drought, but obviously increased wildfire concerns. I mean, it seems like every year in California, the wildfire season gets longer and more intense. And again, is that climate change? It has all the signatures of climate change, although I avoid calling any one event like a climate change event, because again, we're looking at the overall trend. What we have seen, and again, I think if you just follow the news, is we've definitely seen an increase in the intensity of storms. So it seems like every hurricane season gets a little bit worse. Last year, we had more named hurricanes than we've ever had in the history of our hurricane naming. You may remember we ran out of the alphabet and we had to go into the Greek alphabet, and we almost ran out of the Greek alphabet before the hurricane season was necessarily over. So that's never good news. And again, we've seen billion-dollar types of destruction and devastation from individual storms, but again, has all the signatures and fingerprints of kind of climate change as we increase the intensity of that hydrologic cycle. And again, the pictures have been just hard to watch, whether this was an older one, I think from Puerto Rico, from one of the storms that whipped across the middle. I mean, like full devastation. We're seeing cyclones reaching their all-time strongest, hurricanes now that are more systematically category 4 or 5 regularly. That was a rarity before, and now they seem much more commonplace. And again, you may not believe in climate change, but the minute that hurricane like this hits you, I think you're going to be a believer in terms of realizing that something needs to be done. So I'll end by kind of saying, because I want to leave time for questions, people may say, oh, it's only a 2-degree change. We can adapt to that, not a big deal. But I will tell you there are all these cascading impacts. It has huge implications in terms of how we grow food and where we can grow food. It has similar implications in terms of our water resources that I showed you from the beginning. If we look at the Colorado and parts of the US Southwest, it has huge implications on our ecosystems. Sadly, although the ocean is only maybe increased a degree or so, if you're a coral living on the Great Barrier Reef, that 1 degree warming that can come is enough to cause you to bleach and be permanently lost. And we're seeing massive damage now around the globe to some of the largest coral reefs around the world. Many say kind of the canary in the coal mine effect, that this is really an indication of where we're at. Unfortunately, maybe a more normal and not an anomaly. So I could spend hours talking about all the secondary effects. In some ways, they're the ones that are going to probably impact you the most, whether it's health or ag or forestry or water resources or coastal areas or ecosystems. But I think I'll leave it by saying, what do we do about it? And that's a great question. And there isn't necessarily a short answer to that. But I want to refer you to a couple things that I think would be great resources to go, and then I'll open it to Q&A. One is, I think there are 2 camps. There's one group that says we need to really do our best to curtail emissions, and that's really more of a mitigation approach. And then there's another camp that says change is coming and we should put our efforts in terms of adaptation. The answer probably lies in between. So even if we're pretty drastic, we're gonna see the impacts of climate change and we need to be ready for those. But I think we also need to be much more proactive in terms of thinking about our emissions footprint and ways that we could actually reduce that. And there's an amazing resource that I'm going to just refer you to because you could spend hours going through. But Paul Hawken, who is an environmental economist, put together an organization called Drawdown.org. He looked at the top 100 ways to address climate change, and he actually got scientists involved to go through and say, how much will it cost? How many emissions can we reduce? And will it really actually impact? I find it fascinating. I'm just showing you the top 10. And it's probably not the top 10 that you would have otherwise expected. The number one, believe it or not, comes back to that refrigerant management, which are those fluorocarbons that are commonly used in cooling for HVAC systems and in refrigerators. And because it's been so prolific, how we dispose of that moving forward, because it has such high intensity in terms of its greenhouse gas impact factor, is a huge concern. There are all kinds of efforts globally now to scale back and move away from these CFCs and HFCs, but a lot of it's already been introduced by the current system that we're going to have to figure out how to get rid of. You'll notice things like wind and solar find their way into there for sure in terms of solar farms and rooftop, but diet is one and food is one that people don't necessarily think about. We've moved to an increasingly meat-based diet across the globe that has had huge impacts in terms of the overall global emissions because meat requires significantly more energy in particular to generate compared to plant-based diets. And surprisingly, we waste a whole lot of food. Upwards of 30 to 40% of global food gets wasted, either at the farm side or at the grocery store side or on the consumer side. But that's something we need to do better in for sure. And then the last actually is educating girls in family planning. There's a lot to be said in terms of the importance of education of women and their role in terms of, some of this is in terms of simply reducing or keeping population in check. Because as you add more people and we go into a more consumer kind of driven end of things, there are benefits to having a smaller population in terms of the footprint. But I think I'll stop there, Sarah, if that's all right, because I know we want to make sure that we have at least a little time for some questions. So I will stop and turn it over to you if there are questions that I can help kind of answer. And I'll stop sharing so I can maybe see folks. It was fast and furious. I apologize for the, I packed a lot in a half hour.
Now, Wes, I think you need to be congratulated for taking an enormous topic and covering it in a big general way so that we can look at the big picture. Bob Fannin asks, how valid are the proposals for developing technology for sucking out CO2 from the atmosphere?
Yeah, great question. I mean, I think there is a whole camp that has gone all in on green technologies. I guess the question, that this is a little bit maybe more of an academic side of me is there are different ways to look at climate change, all right? There are ways to look for the Band-Aid solution that says we're not going to change our ways. We're just going to find ways to actually say, come with a technological solution that saves us on the back end. And some of the green technologies put forth, I think, have really kind of gone that route. It hasn't done as good of a job of addressing the emissions on the front end, and has actually focused instead of looking at, well, if we can come up with technologies to remove it on the back end, we don't necessarily have to change our ways. That said, I do think there has been some good strides in terms of looking at carbon sequestration technologies, I would say as part of the solution. But I would be nervous to say that it is the solution. And again, there are some kind of large scale pilot examples of people trying to look at actually sequestering CO2 through a number of different mechanisms. So I'm a little bit of a skeptic, again, if that's the answer that we're going to come up with, but I will say technology is certainly going to play some role in this whole process. But I think if done without asking us harder questions about I'd even go so far as to say, you know, we've developed an economy that is so pro-growth that it's hard to see us ever curtailing our emissions because it's always about bigger and bolder and more stuff. And for me, I spent a year in Sweden on a sabbatical, and it was one of the most eye-opening years I've ever seen because I've seen what simple living looks like. And it gave me some hope to realize, like, actually, we don't need all this stuff that we seem to think we do, particularly in the US, where our houses are full of stuff, as well as actually looking at ways to incentivize the right decisions. You know, we tend to heavily subsidize fossil fuels. And, you know, we pay what, a couple bucks a gallon for gas. If you live in Sweden, you're paying about $10 a gallon of gas. And I promise you that changes people's behaviors really quickly. Everyone bikes, everyone walks, they use public transit. So there are ways for us to bring about some large scale behavior change that's going to have to be part of that discussion.
I have a question.
Nope, sorry, you gotta wait just a minute, Seth. Let me ask these, let's have the questions through the chat, please.
All right.
Nancy says, tell us how carbon dioxide is measured.
Yeah, no, it's pretty straightforward to take a sample of the air, and you can use, you know, we even have technologies. There are plenty of labs that have technologies where you can actually just measure the CO2 content. I won't get into the chemistry behind it, but it's a pretty routine, regular measurement. There's not a lot of uncertainty in terms of the actual data that's coming out of those. And if you want, off record, I'm more than willing to provide you the details, but it's actually not, it's not one of the more complex things for us to measure.
Here's the question everybody wants to know. Your background shows the sheep lawnmowers. Will they return? Asked Susan.
Oh, I know. I was joking with the group before. Like, I hold on to this image because this was one of the favorite projects that we had kind of piloted. I grant it's a really small scale, but for those that don't know, when we put the solar farm in across the front gate, we ran into all kinds of issues because as the grass grows up kind of around each of the panels, we had to go in, someone had to go in with a lawnmower or a weed whacker to remove it all. And then we were approached by Steve Wood, whose picture's in the back, a local farmer here in Travelers Rest, who had a flock of sheep that he was willing to lease to us to do what we deem landscaping. That was the new term we came up. And they were actually surprisingly effective with oversight. We did have to rotationally move them around the solar farm to make sure they weren't all eating in the same spot all the time. But it was relatively cost effective for us to do and help keep the grass kind of low. The downside, when COVID kind of hit, we had to scale back on a bunch of things, and that was one of the COVID casualties. I'd like to be optimistic that maybe in a year or so we'll bring them back, but I will definitely keep you posted. I get more phone calls about concerns of the sheep and where they went. They're in good hands with Steve, and we're in constant conversation with him about the possibility of trying to bring them back. I'd love that. I'd love to have them come back. I thought it was a great project.
Dan Sheska says, how do we keep Greenville green? For example, in Travelers Rest near Bojangles, they're developing that land by cutting down every tree, as an example, and downtown is the same.
Yeah, that's a tricky one. I mean, I think the city, there are groups like Trees Upstate and others that have helped kind of, I think, elevate the conversation. One of the problems with a place like Greenville, where development seems to outpace the policy in a lot of ways. I mean, developers seem to always be kind of ahead of the curve. And honestly, I've watched even in my neighborhoods, in my neighborhood when it was built, you know, from a developer standpoint, it's hard to leave a lot of trees intact. It's easier for them to come in and literally clear cut it all, regrade and flatten out all of the plots before they go ahead and put in the development. And it's frustrating. It's hard to see. They strip off all the topsoil. They take out all the trees along the way. Someone told me, I thought it was kind of very telling, that a lot of the times the neighborhood you lived in was named after the organism that it displaced that used to live there. So if you live in Fox Hollow or Bear Creek or any of these other places, yeah, I find it kind of ironic that usually you're right. There used to be foxes and bears and quail here, and now they have been displaced by suburban sprawl. I will say on the flip side, the city is very aware of this. If you read GVL 2040, there is a definite commitment to trying to preserve green space. And so it's something very much on the forefront of Knox White and City Council and others. There was even a call recently, obviously there was a group trying to actually impose a moratorium on all building for us to kind of help kind of get out ahead of the curve for that and affordable housing and other things. So it is a pertinent conversation, one that I think we've had some successes, but to your point, I mean, it's when new development comes in, unfortunately, they're not just clear cutting, they're taking out every blade of grass, shrub, everything along the way. And it's something we got to keep asking.
Yeah.
Oh, let's give just a second. Maybe he'll unfreeze. There we go. There we go. You're back.
Oh, was I frozen?
Just a little bit, the last sentence.
Climate change.
Yeah, George Fletcher is next to me and can't get to the chat. His question is, tell us more about Bob Inglis's solution of a carbon tax.
Yeah, and so some of you probably are familiar with Bob if you're from the area. Bob has I encourage you to go look at his website. It's republicen.org. He has been a real advocate on instituting a carbon tax. So there has been a fair number of folks that have said one of the problems we have with carbon dioxide as a potential pollutant is it ends up being kind of an externality in a lot of the way we price things, and that because it doesn't get factored into the cost, that we're not really paying the true price on a lot of these things. And so one way around that would be to institute a carbon tax where you use the current kind of market economy to put a price on carbon that then provides a mechanism to actually maybe drive behavior, industry, and other things to a more low carbon type of operations in society. And he has found ways to kind of do a switch, so it's not just a raise-in tax. And again, I encourage you to go look at republicen.org, where he lays out kind of what exactly that looks like. It has definitely gained some traction. I think one that politically has some supporters on both sides of the aisle, which is rare these days. And so it'll be fascinating to follow. I was just on a call with a webinar with him last week with Upstate International, where he was talking about his idea of a carbon tax. And it resonated quite well with a lot of the listeners and folks on there. So yeah, he is continuing to do the hard work that he has done, even though he's not in the politician role anymore, but working with particularly conservative politicians around climate change and some of these solutions that are more market driven.
And Nancy Kennedy put that website, excuse me, in the chat. So you'll be able to see it as well as hearing Wes mention it.
Yeah,
Next,
that's awesome.
Nancy Dixon says, how successful would curtailing meat production be in such a meat-loving culture?
Yeah, I mean, this is the hard, climate change. Everyone's for climate change in terms of trying to come up with solutions until it directly impacts their personal lifestyle. I think that's always been a challenge, right? So if you were to go out and ask most folks, should we do something about climate change? I think the large majority would say, yes, let's do it. And then you say, well, would you be willing to change your diet, to kind of do your share? And then all of a sudden the interest seems to kind of wane. Again, this is one of those things just on a pure scaling side. If, I'm not a vegetarian. I've been vegetarian at different points of my life. I would say I'm not a heavy meat eater either. And I think what we need to aspire to is just if people could individually look to curtail meat consumption, even somewhat, it does actually make a difference. If people always ask me from a personal standpoint, like what's the one thing that I could do personally that has the greatest impact environmentally, sustainability, et cetera. And, they will ask, oh, it's shorter showers or dual flush toilet. I mean, they'll always come up with something, or I turn the water off when I brush my teeth. I'm like, that's great. But honestly, from a water standpoint, from an energy standpoint, from a climate change standpoint, honestly, diet is probably the single individual kind of personal choice that people can make that probably has the biggest impact. But to Nancy's question, that's a hard sell, right? I mean, you have to get people kind of on board with that. And the American lifestyle is, it's hard to find vegetarian options even at some restaurants these days, let alone it being flipped where it's mostly vegetarian and then, a few meat options. So you're going up against a pretty large marketing effort, I think, in terms of making that shift. But it's something, I think worth pursuing. And again, you saw it on the list, number 5 globally on drawdown.org. You will see that a plant-based diet actually has a significant impact. And Paul Hawken quantifies how big that impact is if we could make that shift.
Okay. Seth Harrison asks, are cost-effective air conditioning systems available now for home use that do not use CFCs?
Seth, that's a great question. And I wish I knew the answer in terms of the HVAC end of things. I know that they've begun to look at a lot of alternatives that are the refrigerant. They've continued to change the refrigerants kind of in it. And there are alternatives that move away from those HFCs or CFCs and others that are kind of in there. I have not followed that technology, but it's coming if it's not already there. But again, you saw that up there. Refrigerant management is number 1. That's the number 1 kind of global industry. So there are a lot of folks working on that per se. And again, we've come a long way in that through a number of global policies to kind of phase that out. But the sad thing is a lot of it is already out there because of all the refrigerators and HVACs and others around the globe. And so the concern now is when we go to dispose of all those, how do we contain all the CFCs and HFCs and stuff that are in there? And that's a bigger worry. But the technology is coming along.
Thank you very much. Thank you.
Okay, and a quick check, Carol Armstrong says, was that other website drawdown.org?
Yes, drawdown.org. And there's a book, there's an excellent book. If you really want to see, it's got great pictures and everything else. It has all the details. That is called Drawdown is the name of the book. But the website has all 100 examples that you can peruse. And they've really put a lot of science. It's not just arm waving. They've really got hundreds of scientists to kind of weigh in and try to put actual dollar amounts behind some of these savings. And I think you could really take a look at it if you want to take a deeper dive in any one of these.
One other comment I'm reading right now, a book by Bill Gates this year, 2020, How Can We Avoid a Climate Disaster, I believe is the title. Well written, easy to read, and filled with scientific background.
Yeah, and Bill Gates has put a lot of his individual wealth to really trying to contribute to making a difference in climate change. So he's been one of the major global players financially to kind of help incentivize folks to begin to move that way.
I know there's other questions and other concerns, but our time is running out. Wes, you've done a wonderful job and we thank you.
Hey, always good to be with you all. Yeah, go DINS, right? DINS Day. Feel free to support OLLI or Shy Institute. And as this pandemic slowly comes to an end, I encourage you to come visit us at the Shy Institute. I'm looking forward to reopening campus sometime in the near future when folks can come back to campus, and love to give you a tour, show you around, and we can talk climate change as much as you want. Thanks, Sarah.
It's great. Thank you so much. Goodbye, everybody.
Thanks, Wes.
Thank you.